Hello, everybody. This is Gul Rahim, and today we are going to discuss another method to measure the rate of a reaction, and this is measuring the change in the mass of a reaction mixture. This method is suitable for those reactions in which a gas is given off, but just keep it in mind that this method is not suitable for those reactions in which one of the product is hydrogen gas because of its very small molar mass, which is just 2 gram per mole. So actually, if we allow to escape hydrogen gas from the reaction mixture, the decrease in the mass of the reaction mixture will be not suitable to determine the rate of a chemical reaction because it will be very small and very slow. However, we can use this method to determine the rate of a chemical reaction for many reactions. For example, here on this page we can see three examples. In the first example, magnesium carbonate is treated with nitric acid, which gives magnesium nitrate, water, and carbon dioxide gas. In the second example, calcium carbonate is treated with hydrochloric acid to give calcium chloride, water, and carbon dioxide gas. In the third example, zinc carbonate reacts with sulfuric acid to give zinc sulfate, water, and carbon dioxide gas. In all these three examples, we can see that one of the product is carbon dioxide gas. Dear students, we know that according to the law of conservation of mass, mass can neither be created nor destroyed during a chemical reaction. In other words, we can say the total mass of all the reactants must be equal to the total mass of all the products in a chemical reaction in a closed container. But if we allow the gas to escape from the reaction mixture, as you can see here in this diagram, then there will be decrease in the mass of reaction mixture with the passage of time, because one of the product, which is gas, is going to escape from the reaction mixture. You can see here in the data at the beginning the total mass here is 196 gram. After 10 seconds we are left with 190 gram. After 20 seconds we are left with 184 gram. After 30 seconds we are left with 180 gram. After 40 seconds we are left with 176 gram. After 50 seconds we are left with 173 gram. And after 60 seconds we are left with 170 gram of the reaction mixture. After 70 seconds, 80 seconds, there is no further decrease in the mass of the reaction mixture, which shows that the reaction is over. So we can measure the rate of this specific reaction by at any time, like at 30 seconds or at 40 or at 50 seconds, by using the formula, that is rate is equal to del m over del t, where del m is change in the mass, actually decrease in the mass of reaction mixture, and del t is total time taken. The unit will be gram per second, and the negative sign here indicates that it is decrease in the mass of the reaction mixture. We can also draw a graph of mass of the reaction mixture against time. We can also measure the rate of this reaction by finding out the gradient of this graph, which is y over x, and actually it is the rate of a reaction. So at a specific time, for example at 30 seconds, for example, we need to measure the rate of reaction, that we have to draw a line with the scale which will just touch the graph at point A, then draw a tangent and make a large triangle, and from this triangle you can find out the gradient of the graph, which will be y over x, and that will be actually rate of the reaction.